Am I audible? Can anyone please in chat box just mention my voice is audible or not? Am I audible? Moving to all, am I audible? Am I audible? Can you message me if you are able to hear my voice? No, not audible. My voice is breaking, it seems, isn't it? అడుగును. Internet speed is bit low. Why? Voice is not clear. I can hear that voice is breaking. So internet speed is low, so that's the issue. Okay. Okay, all of you, can you join after half an hour because internet speed is slow? I have to give some complaint to the person who is giving me connection here. Okay, so I start the class. I will start the class after half an hour. I will recheck the internet, or shall I start the class? 2, 3. The internet speed is low. Let us join the session at 2 p.m. So I will take As soon as I send this message that my internet connectivity is good, I immediately converted into excellent. You can see, I think, if you are, yeah, you can see it is showing excellent here. So, am I audible? Can you please inform me? Am I audible? Am I audible now? Now it is okay, it seems. Till now it was showing poor. Now it is showing excellent. Yes, okay then. Now let us continue. Let us start the session. Already it has been, already half an hour is wasted. Now it is showing excellent. Now let us continue the session. If any of your friends have left, inform them to rejoin the session. Our internet has resumed. Okay. I was about to raise a complaint against the internet, an issue that I have regarding this speed. The person who is in charge for this connectivity. Now it's okay. Now let us start. Maximum power transfer theorem. So today's topic is maximum power transfer theorem. If what to say? If I'm able to complete the theory and numerical problems within short time, I will even discuss one more topic today. Okay. So let us see what is meant by maximum power transfer theorem. So maximum power transfer theorem, it states that, I will just take it later. It states that the maximum power is delivered from a source to a load when the load resistance is equal to the source resistance. Okay. So let me explain with a circuit. You can see a circuit here. In this circuit, you can see a source. This is a DC source. This is a DC voltage source. Plus and minus. Okay, this is a DC voltage source, and this is a series resistance which is connected to this DC voltage source, and this is the load resistor. Okay, this is a load resistor. Okay, so the series resistance, whenever a resistor is connected in series to a voltage source, we can say that that is the internal resistance of this voltage source. Okay, so now there is a source, voltage source, there is a load RL, resistive load RL. So now from this source, energy has to be transferred from this source to the load. Okay, energy has to be transferred from this source to the load. So whatever power that is transferred from the source to the load, it will be maximum if a condition is satisfied. Okay, power transferred from the source to the load should always be maximum, isn't it? What are the purpose of connecting a source to the load is what? Load needs energy, and that energy is obtained from the source that is connected to the load. Now whatever power that is transferred from the source to the load, it should be maximum. So that condition is possible only when if the load resistance is equal to the source resistance. What is the source resistance? It is nothing but the series resistance to the source. Okay, or internal resistance of the source. So just now I told you that Rs is the internal resistance of the source. So if the source resistance, okay, is equal to load, or if the load resistance becomes equal to the source resistance, then power delivered from the source to the load will be maximum. Okay, so once again let us see the statement. It states that the maximum power is delivered from a source to a load when load resistance is equal to the source resistance. That means that I will take a pen. I know I can't write with my pen, means my cursor won't listen to me, but I will try to write. So maximum power is delivered from the source to the load. This is our source. Okay, this is our source and this is our load RL. Okay, this is our load RL. So from the source to the load, power has to be delivered. Okay, so maximum power, Pmax, power will be maximum only when, means the power delivered to the load will be maximum only when this RL is equal to RL is equal to RS. RL is equal to RS. I'm unable to write yes. Maybe I'm pressing this cursor very hard. So I tried my best and I succeeded. So RL is equal to R. So whenever load resistance is equal to the source resistance, then power delivered to the load will be maximum. Okay, so maximum power is delivered from what? From source to load when load resistance, that is RL, is equal to source resistance, that is RS. So when RL is equal to RS, then maximum power will be delivered from source to the load. I will erase the certain lines. Okay, so this is our RL, this is our RS. So here I can write what? RL. This is RL. RL is equal to what? Series resistance, that is R. So if you want, you can write it down. You just write down the statements. I will erase all inks. It's better to erase all inks, and I will just put this plus and minus here. Okay. You can write it down and draw the circuit. While I am explaining, you can write it down and draw the circuit. Now, from the source, definitely we know when source is connected to the load, current will flow in the circuit. And then the current in this circuit is I. Okay, current in this circuit, current flowing in this circuit is I. This is I. Okay, so current in the circuit is I. So what is I now? If I want to determine I value, what is I? I is equal to V divided by the total resistance. It's a single loop circuit, isn't it? It is a single loop circuit. So total voltage by I is the total current in the circuit, isn't it? It's a single loop circuit, so I is the total. So total current is equal to total voltage by total resistance. Total voltage is the source voltage and total resistance is what? Series resistance plus load resistance. So I is equal to V by RS plus RL. Okay, I is equal to V by RS plus RL. So if people quickly write it down, if you complete, type C in the chat box. If you type C in the chat box, I will continue. Write it down as quickly as possible. As soon as you complete, just mention in the chat box that you have completed. Now, so we were discussing about maximum power that is delivered to the load. Now, what is the power in this circuit? So I hope you might be knowing the formula for the power. Okay, so formula for the power is P is equal to I square R. Now I want to determine the power delivered to the load. So power delivered to the load is what? P is equal to I square into RL. Okay, so what is I square? Just now in the previous slide I have shown, you might have from the previous slide you might have written the current equation. So what is I? V by Rs plus RL. So I square means V square by Rs plus RL whole square. So P is equal to V square into RL by Rs plus RL whole square. Simply substitute the equation of I here, you will get this expression for power. Now we want to determine maximum power that is delivered to the load. So maximum power that is delivered to the load. Okay, so what is our load? RL is our load, resistive load. Okay, so if whenever we want to determine the maximum power that is delivered to the load, simply what we have to do is we have to differentiate the power with respect to load and equate it to 0 to determine what? To determine the maximum power. Okay, that is the condition. Okay, what is the condition here? Whenever I want to determine the maximum power, what I have to do is, what is power? P. So what I have to do is, I have to differentiate power with respect to the term across which I have to determine the power. So what is the term across which I have to determine the power? That is the load. Which load? Resistive load. Okay. So to whichever parameter I want to determine the power, maximum power, I have to differentiate power with respect to that parameter. So that's what is done. This is, I want to determine maximum power. So what I have to do, I have to differentiate power with respect to the element across which I have to determine maximum power. So differentiate P with respect to RL and equate it to 0. So what is P? This is P. Okay, so that is P. So write down P here. You can put a bracket here. I didn't. So listen to me. You can put a bracket here. Again. This is P. So differentiate this with respect to RL. So if you differentiate with respect to RL, you will get this expression. Okay, V square into Rs plus RL square minus 2RL into Rs plus RL whole divided by Rs plus RL whole to the power of 4 is equal to 0. This is what you will get. So I hope you might be already knowing how to differentiate the expressions. So just write it down. If you complete, just type C in the chat box. While I'm explaining, you can write simultaneously while I am explaining the content, so that immediately when I ask you to type C, you can type C in the chat box. Okay, then now for the simplification, you can see, you can send this denominator to the right side, it will become 0. So what is left? And you can what to say, and here V square also, it is, if we have V square is common here, that also if we send to the right side, it will also 0 divided by anything, it is gone. So what is left over after simplification? For the simplification, you will get Rs plus RL whole square minus 2RL into Rs plus RL, and you just expand this first expression, you will get Rs square plus RL square plus 2Rs RL minus 2RL Rs minus 2RL square equal to 0. So here if you observe, these two terms, one term is positive, one term is negative. So these two terms can be cancelled, and so here and further, if you observe these two terms, they can be cancelled. Okay, these two terms can be cancelled. This minus this, and here 2RL square, and here minus 2RL square. This is plus RL square. So minus 2RL square plus RL square means only RL square is left over. So RS square minus RL square equal to 0 you will get. Okay, one or to say one expression is missing here in between. RS square minus R RS square minus RL square. I'm sorry, that is L is equal to 0 you will get. Send RL to other side. Send RL. I didn't take RL. This is RL. Yeah, L succeeded. So now send RL square to the other side. So what is left? So RS square minus RS square will become equal to RL square. So RS is equal to RL. Okay. So for the maximum power to be delivered to the load, this condition, that is our load resistance should be equal to the source resistance. Okay. So just write down the statement: maximum power will transfer to the load when load resistance is equal to the source resistance. Write it down quickly. Write it down quickly if you complete in form. Okay. Unfortunately, I just touched the plus and minus button on my keyboard, and you can see what is happening. If you complete, just type C so that I can proceed. Shall I change this slide? Okay, I'm changing this slide. Now let us see what are all the steps that are to be followed to to determine the maximum power in the given circuit using maximum power transfer theorem. Okay, so for that, let us consider a circuit shown in this diagram. Okay, and first step that is to be followed is this is minus, this is smaller terminal, this is big terminal, and this is plus, and this is minus. Okay, so here the first step that is to be followed is similar to, if you know Thevenin's theorem, so maximum power transfer theorem is almost similar to your Thevenin's theorem. The first step is to remove the load, okay, open circuit the load terminals, and to determine Thevenin's voltage, and to determine what? And to determine VTH, Thevenin's voltage. So first step is to remove the load, okay, open circuit the load terminals, and across the load terminals we have to determine the VTH. Okay, so roughly with free hand, as quickly as possible, you can draw the circuits. With free hand, as quickly as possible, draw the circuit. If you complete in form, Draw it as quickly as possible. Draw it, and if you complete, just mention in the chat box. Completed, very good. If you people draw quickly, I can discuss. Means I will conclude this session as quickly as possible. In step two, what you have to do is step two. Okay. Step 1 and step 2 earlier I have joined. Step 1 and step 2 here I have written B Thevenin. So in step 2 no need to write this. I have joined step 1 and step 2 there. Now in step 2, this is our step 2 now. In step 2 what we have to do is we have to remove the sources. If there is a voltage source, what we have to do in Thevenin's theorem, what we used to do is, if there is a voltage source, then we have to short circuit. If there is a current source, then we have to open circuit the terminals. Okay, to determine what? In step 2, we are going to determine the RTH. I will erase the. Okay, so step 2 is to find R Thevenin. Okay, to determine R Thevenin, what we are going to do is in step 2, we are going to either short circuit the voltage source. If there is a voltage source, we must show. Here we have a voltage source in this diagram which I have shown in the previous slide. In the previous slide, there was a voltage source. So what we have to do, we have to short circuit this voltage source. To short circuit the voltage source, this R1, instead of drawing here, I have replaced its position. It doesn't matter. It doesn't matter. Okay. So you can draw here or here. It doesn't matter. In the same branch, you can place the elements anywhere in the same branch. Okay. It's not going to make much effect. So in our step 2, okay. So what we are going to do is, we are going to determine R Thevenin. So determine R Thevenin, we have to open circuit the load terminals and short circuit the voltage source. Don't write the theory. What you have to do is, you have to write, I will tell you what you just write step 2 and where is my cursor? Here it is. Step 2 and write find RTH. Just up to here you just write from here to here. That's it. This is this portion which I have selected, that you people write and draw this circuit. That's it. Don't write the whole theory. So step 2 is to find the RTH. Did you complete? I will change this slide. Just write step 2 and write find RTH and draw the circuit with free hand. Okay, so I'm with some other connecting device. I'm looking at the chat messages. So if you people message me as quickly as you message me, and I will change the slide. Just draw the circuit and write step 2. Did you complete? It won't take much time to get this circuit. This points. Don't write the whole theory. Okay. Now step. So my step sequence has changed now. It's okay. It has changed. It's okay. Now this is step 3. This is step 3. Okay. So in step 3 we have determined. Now we have determined VTH. We have determined RTH. We have to, in step 3, what we have to do? You have to draw the Thevenin's equivalent circuit. Okay. So this is Thevenin's equivalent circuit. Okay, VTH, RTH. Okay. So here I have written replace the network by VTH and in series with RTH I have written like this. So simply you can write Thevenin's equivalent circuit. In step 3, Thevenin's equivalent circuit. So draw the Thevenin's equivalent circuit and reconnect the load. Okay, that is step 3. Next, step 4. In step 4, we will determine RL value. What is RL? If according to maximum power transfer theorem, if maximum power is to be delivered to the load, then RL should be equal to RTH. So simply write down in step 4, RL equal to RTH. That's it. No need to draw the diagram. If you want, you can draw and you can write this RL equal to RTH. If you want, you can draw. No need to draw at all. Okay, no need to draw this. So no need to calculate RL at all, because here we are determining maximum power delivered to the load by maximum power transfer theorem. So when we implement maximum power transfer theorem, we must consider RL is equal to RTH. So to find RL, that's what I have mentioned in step 4 there. So no need to find. Simply we must write RThevenin value, whatever you have got. Already we have calculated RThevenin. You know how to calculate RThevenin, I think so. So if you know how to determine RThevenin, simply replace RTH value with RL value with RTH value. If you complete, just mention. No need to draw the second circuit, because already you have drawn in the previous, in step 3 I have drawn the circuit. Same circuit I have drawn in step 4 also. No need to draw. If you complete, I will change the slide. I'm changing the slide. I hope you have completed. If not, if you have not completed, you can mention in the chat box that you have. You just type N so that I will go back to the previous slide. I'm changing the slide and okay, now this here it is mentioned step 6, but it is a step by account to based on what I have started at the earlier stage. So this is our step 5. So in step 5 we will determine the maximum power. Okay. So now what is IL from the circuit which is in the previous slide, from the circuit which you have already drawn, it is there in your notes. So what is IL from the Thevenin's equivalent circuit? We get VTH by RTH plus RL. Okay, VTH by RTH plus RL. Now RL is equal to RTH. So I can, instead of RL, I can add RTH. So IL is equal to what? VTH by 2 RTH. Okay. Or I can write VTH by 2 RL. Okay. So either you can write this or you can write this. Both are same, because RL equal to RTH. That's why either you can write this equation or this. No need to write both. Here I have written both, because we are just learning the concept, that I have written both, but don't write both. You can write any of these two. Okay. Now we have to determine maximum power. Okay. Power equation we already know, IL square RL. Okay. And no need to write IL or I is same. Here did I write IL? Okay. Here I have written IL, so that's why we are writing IL. No need to write. If you write I here, okay. If you write I, you might have considered IL. It's okay. So there I have considered IL, loop current as IL. That's why I have written IL square RL. So what is IL square? Okay. You write this equation or this equation, your wish. I have written this equation. Okay. I have taken this equation. You can write any of these two equations. So IL is what? VTH by 2 RTH. So IL square is what? VTH square by 4 RTH square into what? Into RL. Okay, here it is RL. So instead of RL, I can write RTH. So if suppose I might have taken this equation, then there is no need to write RTH here. We can write RL. So RL will be cancelled. Okay. So I hope you are able to follow. Okay. So here it is RL, IL square. So instead of IL square, I have written this equation now from the above, this one. So if there is a denominator RTH, in the numerator if I write RL, instead of RL you can write RTH, isn't it? Even if you write RL or RTH, it doesn't matter. In maximum power transfer, both are equal. So now RTH and RTH square is there. So RTH, they will cancel in the denominator, only RTH will be left over. So what is P maximum? P maximum is equal to V square RTH by 4 RTH. So this is our P max. I am trying my best to write. Okay, I have succeeded. Successfully completed. This is it. This is the equation for P maximum. So directly after telling you the statement, I might have gone to the numerical problems. I might have started solving the numerical problems, but for this maximum power equation, I didn't directly go for the numerical problems because I wanted you to know the expression for the maximum power. So formula for maximum power is VTH square by 4 RTH. So I can write, instead of RTH, I can even write RL. Okay, RL is nothing but RTH. If you complete in form, we will start discussing numerical problems. So this is our step number 506. Okay, because I wrapped 2 steps at the beginning, that's why our step count has changed. It is not matching with the slides. If you complete, please inform. Completed? Shall I change the slide? You are taking much longer time. Am I in the class? So let us see the numerical problems. So in the first problem, determine the value of the load resistance that receives the maximum power from the supply source and maximum power under the maximum okay, under the maximum power transfer condition for the below circuit. So what you have to determine here is determine the value of load resistance. You have to determine load resistance, okay, value when it is receiving maximum power from the supply, and we have to determine the maximum power value also. So we have to determine the load resistance or RL value and maximum power value. Okay, so this is a given circuit. This is a given circuit. Write the question and draw the circuit as quickly as possible. I will just check how many concurrent viewers are there. Viewers are not visible here. Here they will usually appear. Very few concurrent viewers are there. Yeah, here it is showing only three. Only three concurrent viewers are there. Okay, so I could see only three members. I don't know how many are there. So I hope you have drawn the circuit. Okay, try to draw with free hand. Try to draw with free hand. So for now, let us solve this numerical problem. So step 1, you do one thing, you people okay, at least one numerical problem you people can just okay, while I'm explaining, you people better if you are able to complete. Okay, while I'm explaining, if you are able to write it down, okay, it will be better. So step 1 is to determine Thevenin's voltage. That's it. Okay. Step 1 is to determine Thevenin's voltage. To determine Thevenin's voltage, what we have to do? Simply you have to open circuit the load. So in this earlier, I don't know whether you have observed or not. I didn't discuss about this circuit. See in the previous slide, this is our source. Here it is mentioned load resistance. This is the load. Okay, so we have to determine load resistance value and maximum power. So in step 1, we have to determine VTH, we have to open circuit the load terminals. Okay, so if you people are drawing and writing, so write step 1 and write VT to find VTH. You can write in simple words. And if you are drawing, simply mention open circuit terminals. Roughly draw the diagram. Don't write values and values of the resistors, because in the question itself you might have already written source values and all. So roughly draw it. Just do the skeleton part. Just draw the skeleton part of the diagram. Whichever term is new in the next circuit, you just mention that term properly. Here our new term is VTH in the given circuit. So across AB terminals, load is removed and VTH is returned. That's it. Okay, write VTH across AB. Now, so shall I copy that circuit? It's better if I will just copy the circuit so that I can explain the expressions. So see here, VTH is what? What is VTH? VTH is the voltage across terminals A and B. Okay, VTH, I will take laser. So VTH is the voltage across what? Terminals A and B. So VTH is nothing but VAB. Okay, so VTH is nothing but VAB. So VAB means what? VA minus VB or VB minus VA. Okay, so VAB is the difference of VA and VB. Okay, so voltage at terminal A is VA, voltage at terminal B is VB. So VAB is, so since I have written A first, so we will write VA minus VB. If I write VBA, we will write VB minus VA. So it's simply in general I can say VAB is the difference of VA and VB. So VAB is equal to, you can write VA minus VB. So what is VA? VA is the voltage at terminal A. Okay, so VA is the voltage at terminal A. These terminals are open So if you see here, okay, so if you see here, across this terminal and this terminal, voltage source is there. In between this terminal and this terminal, two resistors are there, R1 and R2. Okay, so I can say 30 volts voltage source is connected in parallel to this branch, where R1 and R2 are connected in series or parallel. R1, R2 are they are connected in series. Why? Because in between there is no current division here. These terminals are open. So if current enters into R1, the same current will flow through R2. Whatever current is entering R1, same current will flow through R2. So we can go for voltage division rule to determine VA. So to determine voltage at terminal A, so if I can write V here, VA here, V. So VA is what? VA is can be determined by voltage division rule. So total voltage V, that is 30 volts source voltage, into C. I can write R1 or R2 here. Why? Because okay, self resistance. Okay, self resistance. I can write R1 or R2. Why? Because V is in between R1 and R2. So here I have considered R2 as the self resistance. You can even write R1. It doesn't matter. Okay. So I am writing R2. So R2 divided by R1 plus R2. Both R1 and R2 are in series, isn't it? So here I have implemented voltage division rule. Okay. So I can even write R1 here. R1 divided by R1 plus R2. It's your wish. Okay. Because VA is in between R1 and R2, that's what. So what is V? Total voltage 30 volts into R2 is 20 divided by R1 is 15, isn't it? R1 15 and R2 is 20. So 20 divided by 15 plus 20, you will get some 17.14. You just do the calculation. If there is any calculation mistake here, you can just you can type the answer if you have calculated before ahead. Okay. Before I tell you the answer, if you have already calculated, you just type the answer in the chat box, or if there is any mistake in my answer, you can inform me. Okay, if you type the answer in the chat box, I will recheck the calculations. So if you have completed, we will proceed. This is VA. This is VA. Now, similarly, you have to determine VB. I hope you have completed. I will copy the same image. I can cut Excel multiplication. So I will and I will paste it in the next slide. Okay. Now if you observe here in this, now we have to I have determined VA. Now I have to determine VB. So what is VB? VB is the voltage at this terminal B. VB is the voltage at this terminal B. Now see here this branch R3 and R4 branch. It is also connected in parallel to 30 volts voltage source. Okay, R3 and R4 is connected in parallel. Parallel, isn't it? This is parallel connection. They are connected in parallel. Okay. So here, here also I am going for voltage division rule. So VB is equal to total voltage. What is total voltage across these two terminals? That is source voltage. Okay. So that is source voltage. That is 30. That is V I have written. Here you can see 30 into C. For determining VA, we have considered R2 divided by R1 plus R2, isn't it? So since you have written R2 in the numerator, for this case, for VB case, the resistance, okay, which is parallel to this R2, you must consider same resistor. If you write R1 in the numerator for VA, you must write R3 in the numerator for VB. Okay, so that thing you have to keep in your mind. So since in the earlier case, in the previous slide, you have in the numerator, you have written R2. So for not determine VB, you must consider R4 in the numerator. So R4 divided by R4 plus R2. Voltage division rule, that nothing else. Okay, so V is 30, R4 is 5, and R3 is 10. So 5 divided by 10 plus 5, just solve it, you will get 10 volts. Okay, so I hope you people, if you are listening carefully, you will definitely able to follow what I am explaining here. Okay, I will just end this show. I will remove this. Okay, yeah, I didn't write VA minus VB. Sure. So we have determined VA value, we have determined VB value. Okay, so write VA value and VB value, and in this expression, that is VAB is equal to VA minus VB. In that expression, just write it and determine VAB value. You have got some value 7.14 V. So VAB is nothing but VTH. Now we have determined the VTH value, that is 7.14 volts. Okay, V means volts. So if you feel that you are unable to follow this session, you can just type R in the chat box so that I will repeat. So I'm trying my best. I'm trying to explain in the simplest way possible. Okay, so that everyone can understand. Completed? Okay then. Now step 2. We have determined VTH, and I think you know in step 2 what we have to determine? RTH. Okay, we have to determine RTH. See here voltage source is there. What we have to do to that voltage source? It has to be short circuited. Load should be open circuited. Okay, source is short circuited and load is open circuited. This is our circuit now. You can write step 2 and write to find RTH in front of step 2, and you can draw the diagram. Okay, don't write everything, just roughly. So I will give you a clue. I will just, so that in order to save time, just draw like this. My cursor won't listen to me, that's the main issue. It's okay, I will try my best. Okay, roughly in your notes, don't put much efforts. I can't draw properly, but I am trying my best. Wasting time, isn't it? I'm simply wasting my time. I can't draw, leave it. Okay, so I will leave. Just draw roughly, don't write all these values, don't write all these values. Just draw roughly. Changing the slide, don't waste time. So let us determine RTH. So RTH, okay, I will copy the diagram here. Okay, so I have to determine RTH. RTH is nothing but resistance in between terminals A and B. RTH is nothing but RAB. Okay, so here, if you see here, there is a short circuit, isn't it? This is a short circuit. Okay, there is a short circuit here. So, because of this short circuit, let us assume, what to say, okay, I'll take a pen, I will try my best to explain. Let us assume from this terminal current is entering. So, what will happen at A? Current will, sorry, at terminal A, what will happen? Current will divide. At terminal A, what will happen? Current will divide. Okay, current will divide like this, isn't it? Current will flow. Okay, in between there is nothing. It's there is a short circuit. Current will flow like this. Okay. Okay. So you can join in if there is no element between two nodes, you can consider those two nodes as one node. Okay, you can consider those two nodes as one node. From that node again current will flow. Okay. At last current will add up here and it will enter into terminal B. Okay. So here how this actually I will redraw the diagram. Let us consider this is terminal A. From here I can't draw resistors, but I am trying. Current is dividing into what? R1 and R, what is it? 2. And what did I say? This is a short circuit and there is no element between this node and this node. So consider that as a single node. From here here again current will divide and it will add up. So here this resistance is R3, this is R4, this is terminal B. Okay, this is it. This is the this diagram. You better draw this. Okay, which I have drawn just now. You better draw it. Okay, then only you will be able to understand how current is flowing, how current is dividing, and all. Can't erase all links. This. So this is it. These two are one nodes. Okay, these two, even though they are two nodes, but since there is no element between two nodes, you can consider those two nodes as one node. So I just wanted to copy this. And because I know I'm talented, I can't redraw again and again. Okay, so from this diagram, which I have redrawn, they have redrawn this into this form. From this diagram, what we can say, R1, R2 are parallel, R3 and R4 are parallel. This dot, you know, this junction, that junction is nothing but these two dots. That junction, this dot, you know, that is nothing but this one. These two nodes I have considered as one. So R1 is parallel to R2, you know how to simplify. R1 is parallel to R2. So R1 into R2 by R1 plus R2. Next, R3 is parallel to R4. So R3 into R4 by R3 plus R4. You know R1 value, R2 value, R3 and R4. Substitute all these in this equation and you will get this expression. Simplify that, you will get the 8.57 plus 3.3 and RTH you will get 11.90 ohms. I didn't use the symbol. But I used the symbol. I don't know why I didn't use the symbol. Okay. So I hope you are able to follow. Someone typed something I didn't see. It says retracted, it is showing. Okay. So I hope you are able to follow. So just listen carefully. You must be able to analyze the circuit. You must, in order to know whether the elements are series or parallel, you must always assume current entering from one end and one junction or one node and see how if current divides or not. If current is not dividing, then those elements are in series. If current is dividing, those elements are in parallel. Okay. So I hope you are able to follow. So I'm continuing, I'm just changing the slide. Okay, now let us go to step number 3. Step number 3, we must draw the Thevenin's equivalent circuit to determine the maximum power. So here I have combined all these steps of Thevenin's equivalent circuit as I have simply written to determine maximum power delivered to the load. So maximum power. Okay, so maximum power, I want to determine maximum power. Before determining maximum power, I must draw the Thevenin's equivalent circuit. So this is our Thevenin's equivalent circuit. VTH, this is what we have got. RTH, this is what we have got. RL, we don't know the RL value, isn't it? Simply we can write RL, but since it is maximum power transfer theorem, numerical problem, therefore RL should be equal to what? RTH. So RL value is 11.90 ohms. Okay, don't write everything on this slide, just write the title step 3 and write in front of whatever I have written. You will just write that maximum power and draw the circuit quickly. Draw Thevenin's equivalent circuit. Don't write this theory. Don't write this theory. You can read this theory if you have completed drawing the circuit. You can read what I have written on this slide, but don't write it. I hope you have completed. Now you can write RL is equal to RTH in the next step. So you can write RL equal to, don't write anything else, just write this line, RL equal to RTH. According to what? According to the maximum power transfer theorem. According to maximum power transfer theorem, RL equal to RTH. You can write that. Okay, simply write according to maximum power transfer theorem, RL equal to RTH. Now you know the formula for maximum power. What is it? VTH square by 4 RTH. So VTH you know, 4 RTH you know, just substitute it. Okay, you will get maximum power value. Just write it down. So let's go to the next numerical problem. Find RL for maximum power transfer and find maximum power transfer to the load for the given circuit. Same thing which was in the previous numerical problem. Here we have to determine the load resistance and maximum power. Same thing. Okay, circuit is given. Okay, they have mentioned RL here. This is our RL, and there is a dependent voltage source and there is a current source. Okay, so this is current controlled voltage source. So this is a numerical problem on dependent sources. Write the question and draw the circuit as quickly as possible. So I hope you have completed. So let us see. In step 1, we have to determine VTH. So for that, what we have to do? We have to open circuit the load. So remove the load. Okay. So write VTH. I have written VOC. VOC means the open circuit voltage. Okay. So you can write VOC or VTH. Okay. So you people roughly draw the circuit and just open circuit the load terminals and mention VOC. Don't draw the whole circuit, just roughly draw it. If you have to draw again and again, it takes some time, isn't it? Don't write all parameters. Don't take more than a minute. Otherwise, this session will extend for I don't know for how much longer time. So if you are able to write quickly, we can conclude quickly. So I will complete this maximum power transfer theorem now, and if possible, I will take one more session today afternoon after 2 p.m. So I hope you have completed. If you have not completed, just type N. If I change this slide, I'm changing this slide. Okay. So this is it. So now what I have done is I have gone for source transformation. So where is this possibility of source transformation? You just see in this previous slide. You just see here, there are these two resistors. They are connected in parallel to a current source. Okay, these two resistors are connected milliampere. This is milliamperes. A is bit far away from M. Okay, so these two resistors are parallel to 4 amperes. These two resistors are connected in series. So 3 kilo ohms and 1 kilo ohm. 3 plus 1, 4 kilo ohms is parallel to 4 milliamperes. So we can go for source transformation. So what is it? This is I. So what is V? V is equal to what? I into it's better if I type. Okay, I will try. If I am unable to write, I will just type it. Okay, so V is equal to what? I into R. I is what? 4 milliamperes. I can't write. It's impossible for me. So what I will do is I will just I will write here. So V is equal to I value is 4 milli small m into, so I'm taking this into from my keyboard. It will look like this star. So 4 millimeters into how much resistance? 1 kilo ohm and 3 kilo ohm. 1 kilo and 3 kilo ohm means what? Both are in series, so you just add those two resistances. So what is it? 4 kilo ohms. So 4K. Okay. So 4 milli, 4K. Milli and kilo will cancel. 4 into 4, 8 volts. Okay. Sorry. 4 into 4, not 8. I simply added it. Instead of multiplying, I simply added it. So don't listen to what I was just spoke. So 4 into 4, it is 16. Okay, kilo and milli will cancel each other. Okay, kilo and milli will cancel each other. So what is left over? 4 into 4, that is 16 volts. Okay, so 16 volts connected in series to which resistance? 4 kilo ohms resistance. So in the next time by source transformation, see here 16 volts, 4 kilo ohms. Anyone, if you are unable to understand, you can just type in the chat box. I will once again explain. You might, if you know how to perform the source transformation, you can easily do it. So now, if you see here, this is VOC. Means VOC is nothing but what? VOC is nothing but VTH. VOC is nothing but VTH. Now, these two terminals are open. This resistance, one terminal of this resistance is open, so no current will flow through this resistance. So VTH is the voltage across 2 kilo ohms, or VOC is the voltage across 2 kilo ohms. So if you observe, this is a single loop circuit. Okay, so this is a single loop circuit. So you can apply Kirchhoff's voltage law here, KVL in this single loop, and you can determine VTH. Okay, so to determine VTH, I am going to implement Kirchhoff's voltage law. So after source transformation, this is our circuit. I hope you people have drawn it. You must draw it. You should draw as quickly as possible. Anyhow, I'll be giving repeating the same statement twice or thrice, isn't it? So meanwhile, you can draw it. Now apply KVL in this loop. Okay, in this loop, apply KVL. KVL. Yeah. Apply KVL. So if you apply KVL in that loop, okay. Shall I copy that in this slide? Yeah, I copied it here, so it will be easy for you to understand. Now see here, you must assume current in any direction your wish. Okay, any direction that you want, you can assume. Okay, so either clockwise or anti-clockwise, your wish. So algebraic sum of voltages 16 volts plus 2000 Ix square. Ix, sorry, this is Ix dash. Okay, so Ix dash. So 16 plus 2000. Here I have written 2k, so I will write k. 2k or 2000 is same. 2k is equal to what? What is that? 4000 ohms and 2000 ohms. Okay. So this, I think I forgot something. I forgot to write this is resistance. What about this current? Voltage across the dependent voltage source. So this is Ix dash, 2k Ix dash. 2k Ix dash is equal to 4000 ohms, okay, 4k into resistance into current. If you see in this branch, it is mentioned Ix dash current. So write the same current, Ix dash current plus 2000, which is 2000 this one, 2k into Ix dash. Okay. So algebraic sum of voltage, algebraic sum of the source voltages is equal to algebraic sum of the voltage drops. Okay, so what I have done in the above expression is I have sent the source voltage to the right side. So if I send all source voltage right side, this will become negative. That's why you can see this is negative, whereas these two are positive. So actually in the above equation I have written the reverse format. First I wrote the voltage drops is equal to the source voltages. So I have sent source voltages. These two are the source voltages. These two are source voltages. When I send them from one side to the other side, if they were positive, they will become negative. That's it, nothing else. Okay. So now simplify this. You will get Ix dash is equal to 4 milliamperes. Okay. So Ix dash you have got. Now this is the resistance. This is the current. So what is the voltage across this 2 kilo ohms? 2k into Ix dash, that is 8 volts. No need to draw this diagram. No need to draw this. I have simply copied it to explain you how to get this expression. I hope it's a very simple expression. I hope you are able to understand. So no need to draw this. Just write these 4 lines quickly. Completed. Okay, then I'm changing this slide. Now let's go to step number 2 to find RTH. To find RTH, since there is a dependent source, we can't simply open the load what we have to do is we have to short circuit the load. When dependent sources are there, okay, if dependent source is not there, you can open circuit the load terminals and short circuit voltage source and open circuit current source. But here, since there is a dependent source, to find RTH, you have to short circuit the load terminals. So short circuit the load terminals and determine the current through the short circuit. So we have to determine ISC value. Okay, we have to determine the ISC value. So from the source that is 16 volts, let us assume the current coming out of the source is I1. Okay, and at this junction, what will happen? Current will divide. It is dividing into Ix double dash and Is. So I1 is dividing into Ix double dash and Isc. So let us assume this node voltage as V1. At this node, voltage is V1. So draw the circuit quickly. Okay. Now apply KCL at V1. I will just copy the circuit here. So if you apply KCL at V1, okay, I1 is the entering current, Ix double dash and Isc are the leaving currents, isn't it? So I1 is the entering current. I1 is the entering current, Ix double dash and Isc are leaving current. So I1 is equal to Ix double dash plus Isc. or I1 minus Ix double dash minus Is equal to 0. Okay. So if you know KVL, KCL, you can solve many numerical problems, almost all numerical problems. So what is I1? I will undo. What is I1? I1 is 16 minus here V1 minus 2k Ix double dash whole divided by 4000. Okay, I1. I will just expand this. Okay, I1, I will take the laser. I1 is 16 minus okay 16 minus V1 minus 2000 Ix double dash. Okay, so actually here this is minus, this is plus, this is minus, this is plus, both are in same direction, so both should be positive, but here I have taken bracket, that's why see minus minus this will become plus. Okay, whole divided by 4000 minus what is Ix double dash? Ix double dash is V1 minus 0. Here reference voltage is 0. So V1 minus 0, we didn't write 0 there. V1 minus 0 divided by 2000. Next again, what is ISC? V1 minus 0. Reference voltage is 0. Okay. So V1 minus 0 by 4000. Okay. So I am not explaining any Kirchhoff's current law here. So if you are unable to follow, then I can't do anything for that. Okay. So you must know Kirchhoff's current law, KCL, KVL and all. If you know what is KCL, what is KVL, you will be able to understand. So this is the expression that I have got. Okay. So here, what is Vx? I'm sorry, not Vx. This is V1, isn't it? What is V1? So V1 is nothing but 2k Ix double dash from the circuit. I have erased the circuit. So instead of here it is V1, you can write 2k Ix double dash. Okay. Sorry, not Ix. Yeah, 2k Ix double dash. Okay. So if you write that here, this whole term will cancel. Therefore, 16 by 4k you will get. So V1 minus V1 by 2k minus V1 by 4k. Just simplified, you will get V1 is equal to something. That is 5.33. So now V1 is equal to 5.33. What is ISC? ISC is the current flowing through 4000 ohms. So V1 by 4k. So V1 is 5.33 divided by 4000, you will get this. Okay, it's a simple mathematical simplification. If you know Kirchhoff's current law, voltage law, you can easily understand. Here we have implemented KCL at V1. Applying KCL, Kirchhoff's current law at V1. Write quickly. Write quickly. Okay, I hope we have determined ISC now. Okay, so we can determine RThevenin. So RThevenin is VThevenin by ISC. So VThevenin means VOC is 8 volts, ISC is 1.33 milliamperes, 1.33, yeah. So you just simplify it, you will get 6000 ohms. RTH, did you write RTH? I'm changing the slide. So RTH, we have got RTH, and RTH is nothing but what? RTH is nothing but RL. That's it, isn't it? RTH is nothing but RL. So I think in the question they might have asked us to determine the RL, find RL. So what is RL now? I will write it here. We have determined RTH, isn't it? Here, what is RL? So I will just take a text. According to maximum power transfer theorem, linked to maximum power transfer transfer theorem, RL is equal to RTH. So RL, capital L, it should be capital L, RTH. Okay, okay. Therefore, RL is equal to what? 6 kilo ohms. I'll just expand this. This is it. So we have determined RL value. To determine RTH, that is nothing but RL value. That's it. So RL is nothing but 6 kilo ohms. That's it. Okay, now I am changing this slide. In step number 3, we have to determine the maximum power. Okay. So maximum power formula we already know, that is VTH whole square by RTH. VTH square by 4 RTH. Okay. So VTH is nothing but 8 and RTH is 6 kilos. So just substitute the values, you will get some 8 by 3 milliwatts, 8 by 3 milliwatts. I didn't simplify it. I will just simplify and I'll tell you. You can type the answer 8 by 3. What is 8 by 3? Can anyone just mention in the chat box? What is the value of 8 by 3? If you type in the chat box, I'll write it here. If anyone types the answer in the chat box, I'll write 8 by 3. How much? Okay, 2.66 milliwatts. Someone has typed. Thank you. 2.66 milliwatts. Okay, so I'm very much talented. I can't even write about it. 2.66. This is point milliwatts. 2.66 milliwatts. Yeah, thank you for giving the answer. So this is the maximum power that is delivered to the load. 2.66 milliwatts is the maximum power that is delivered to the load. That's it. So let us solve one more numerical problem on AC circuit. We have seen DC circuit problem, we have seen dependent source problem. Let us solve a numerical problem on AC circuit. So in this numerical problem, we have to find the value of the impedance, load impedance for maximum power transferred to the load, and we have to calculate maximum power. Same thing, same question is same, question is not changing. We have to determine the value of the load and we have to determine maximum power. Write the question and draw the circuit quickly. Okay, completed. Now first step, I hope you might be already knowing. What is our first step? First step is to open circuit the load terminals and to determine the Thevenin's voltage. My cursor, this is here. Thevenin's voltage. Step 1 is to determine the Thevenin's voltage. Don't write the theory what I have written here. Just write step 1 and write to calculate or to find Thevenin's voltage and redraw the circuit, draw the circuit roughly. I hope you have drawn roughly. So here if you observe in this minus 2J, no current will flow. So VAB means VTH. VAB is nothing but VTH. Okay, it is the voltage across 4 ohms resistor. So it is the voltage across 4 ohms resistor. So it's a single loop circuit. So you can assume some current I, and you can apply Kirchhoff's voltage law. That's it. Okay, so even if you won't draw this, it doesn't matter because no current will flow. So now see here, VTH is nothing but voltage or VOC, yeah, VAB, VAB, yeah, acha. So VTH is equal to VAB, so that is equal to what? Voltage across, oh yeah, instead of going for Kirchhoff's voltage law, I have gone directly for the voltage division rule. That's what I have done here in the next slide. Okay, so I always won't think in the same pattern. Okay, so my thinking pattern always changes. So what I have done earlier is I have gone for voltage division rule. So I have considered total voltage into voltage across means resistance or the impedance, okay, of the element across which I have to determine the voltage. That is 4 ohms. So 4, where is it? 4 divided by 4 plus 4j. Series to 4 ohms. What is there? 4j is there. Current will flow like this, and like this. Current will not divide here. So 4j and 4 ohms are in series. So 4j and 4 ohms are in series. So 40 at an angle of 0 degree into 4 by 4 plus 4j. If you simplify that, you will get 28.29 at an angle of minus 45 degree volts. You can check if you have scientific calculator. You definitely need a scientific calculator here. If you observe carefully, here in the numerator there is a polar term, in the denominator there is a rectangular term. Okay, so in such case, what you have to do, this if you have to divide 4 divided by 4 plus 4j, you have to convert this rectangular form into polar, and you have to divide the magnitude terms and subtract the angular terms, and later whatever answer that you get, you have to multiply with this. Magnitude should be multiplied and angle should be subtracted, means added. For multiplication, you must add the angles. Okay, so after that you will get this answer. So if you know the rectangular to polar conversion, okay, you can do it. Just copy it down now to save time. So step number 2, to find Z Thevenin. Okay, here I'm using the term Z. Why? Because here reactive elements are also there. So that's why I'm using the term Z instead of R. So Z Thevenin. So what you have to do, voltage source has to be short circuited and load has to be removed. Okay. So this is a modified circuit to determine. Step 2, to calculate the or to find the Z Thevenin. So I have written Z Thevenin there. Here I have written ZAB. This ZAB is nothing but ZTH. Okay, so redraw the circuit. Don't write the theory that is shown on the slide. If you want, you can read the theory. I hope you have completed drawing the circuit. Now, assume current is entering from terminal A and it is flowing like this. At this junction, current will divide. That means what? This 4J and this 4 ohms both are in parallel now. Earlier they were series for determining VThevenin, if you remember. Now for determining ZThevenin, now they have become parallel. Okay, so here there is no source, but we will assume as if there is a current flowing into the circuit from terminal A. So in order to know which element is series and which element is parallel. Now 4J and 4 ohms both are in parallel. Okay, so we have to simplify this. So you have to simplify this. What is it? 4 into 4j divided by 4 plus 4j. Okay. So here I have, see here I have written here. This is it. 4 into 4j by 4 plus 4j. So this 4 is the real part. 4j is the imaginary part, isn't it? So if you have real part, 4 plus, sorry, 4 plus j0 you can write. I didn't take eraser. J0 into 0 plus 4j. This is it. This numerator I have expanded. Okay, I have expanded the numerator. Now you can multiply. Okay, 4 into 0 plus 4 into 4, it is 8j plus this is 0 plus okay. So 4 into 0 and 4 into 4j, 0 into 0 and 0 into j. It's okay. That's it. You will get 8j. Okay, directly, no, without even expansion, you are getting the same value. Okay. After that, you have to convert. Since you have to divide numerator and denominator, you have to convert that into polar form for division purpose. Later, whatever value that you get, the impedance value that you get, that impedance will be in series too. I will show it here. This impedance, at last, after solving these two, whatever impedance that you get, that impedance, okay, don't worry about this line, that will be in series to this capacitor. See here, this is ZAB. Okay, that will be in series to the capacitor, that is minus 2j. Okay, that will be in series to minus 2j. So directly have written here minus 2j and have simplified it. Okay, you people with scientific calculator, you solve it and get the answer. If you are unable to get, you can mention in the chat box. I will tell you how to solve it. So you must know rectangular to polar conversion, when to multiply, when to divide, which terms can be multiplied, which terms can be divided. If you want to perform addition and subtraction, do it using rectangular form. Now, okay, these are in rectangular form. Where is my cursor? Yeah, these are in rectangular form. If you want to perform multiplication or division, better to convert into polar form. Multiply the magnitudes or divide the magnitudes and add the angles if for multiplication, subtract the angles for division. So at last, after simplification, I have got Z Thevenin as, or ZAB as 2 ohms, and Z Thevenin is nothing but ZL, load impedance. So ZL is 2 ohms. Just write it down. If you complete, mention in the chat box. I will try to conclude within 10 to 15 minutes. Okay, I hope you have completed. Next, in step number 3, I am going to determine the maximum power that is transferred to the load. I know the formula P max is equal to VTH square by 4 RTH. Here our term is not RTH, isn't it? It is ZTH. I will write Z here. Okay, so it is ZTH. So I have changed it. So whatever ZTH is there, you just write down ZTH value, VTH value, and simplify it. Okay, see here. This was in polar form, 28.29 at an angle minus 45 degrees. It was in polar form. I converted into rectangular. After that, I just okay. So I just after here 20 minus 20j whole square is there. So I have simplified it and again I converted into polar form. So I have got 800 at an angle of minus 90 degree. So 800 by 4 into 2, 800 at an angle of minus 90 degree watts is my maximum power. I hope you have completed one more small numerical problems and we will conclude this session with feedback. Google form, I will forward the Google form. This is the last problem in this topic. So it's a DC numerical problem. So here wherever sources are there, you can see multiple sources are there, isn't it? 3 sources are there. This the after this problem I will conclude and one more small topic is there that I will discuss today afternoon, maybe after 3 p.m. Sorry. So there are 3 sources and you can see here it is mentioned load RL. This is our load. So find the value of RL for maximum power transfer and calculate maximum power. So same question. Question did not change. Question is same. Circuit diagrams are changing. Circuits are changing, but question is not changing. Okay. So write the question, draw the circuit. Within 10 minutes, I will try to conclude. Completed question. Okay. Now we know first step is to determine VTH, open circuit the load. So step 1 to determine VTH, open circuit the load. So if you remove load, this is our circuit. A and B terminals are open. VTH I have written there. Okay, so redraw the circuit. Okay, so terminals are open means even though source is there, no current will flow because of this 10 volt source because this terminal is open. So no current will flow through this 2 ohms. So this is a single loop circuit now. So apply KVL in this single loop. What do you get? 3 minus 2 into I, loop current I, again 2 into I, minus 6 volts equal to 0. See here, 3 minus 6. Why minus? Why? Because here you see this is plus, this is minus, this is plus, this is minus. Both the sources are opposite each other. So 3 minus 6, okay, minus 2 into I. Again minus 2 into I equal to 0. So just simplified, you will get I value. Draw the circuit, write down the equations quickly. When our voltage source is there, if it is a DC source, don't forget to mention plus and minus. Okay, here in this circuit, in the figure, it is not mentioned, but you people write down plus and minus at the terminals of the voltage sources. I hope you have completed, I think so. So whenever you just observe here, what is the current? Minus 0.75 amperes. Minus means actual current direction is this. Okay. We have assumed clockwise, but actual current direction is what? Anti-clockwise. Okay. So answer, magnitude will not change. Even if you take wrong current direction, magnitude will not change. Only minus you will get minus. Okay. You have got minus. Why? Because the actual your current direction was clockwise, but since you have got minus, that means that the actual current direction is anti-clockwise. So I hope we have completed. Okay, now we have to determine VTH. So I will just copy the diagram in this slide so that you will know how to write the equations. So see here. Now we have to determine VTH. We have determined current through 2 ohms. This 2 ohms current is how much? I is the current. Okay. So now let us start from terminal A and move towards terminal B. Okay, from here. So from here we will start and we will move towards terminal B. So what is the voltage across 2 ohms? 2 into I. Voltage across 2 ohms is 2 into I. Next. What is the this voltage? 6 volts. Next. So next, this is what is the voltage across this 2 ohms? No current is flowing. So 2 into current is 0. Next, what is the voltage across this source? That is already 10 volts. Okay. So see here, if 6 is positive, 10 should be negative. Okay, 6 I have to consider positive because current direction you just see from positive to negative, negative to positive. This is positive, negative. Current direction I have assumed like this, positive to negative. The arrow mark is going down. From here, what about this arrow mark? This is the arrow mark. It is traveling from negative to positive. So if one is positive, another should be negative. And one more term is what? VTH. Okay, so negative to positive. Here negative to positive you have considered minus 10. So for VTH also you must consider minus VTH. I hope you have not understood. So see, now we have considered this loop. This is our loop. Okay, you can assume any current direction. Okay, you can assume any current direction, either clockwise or anti-clockwise, your wish. Okay, what are all the voltage drops here? One voltage drop is VTH, another voltage drop is this 2 into I, another voltage drop is 6 volts. One more element is there, 2 ohms. Of course, there is no voltage drop, but there is a resistor. There is one more element. Total 1, 2, 3, 4, 5. Total 5 parameters are there. So for total 5 voltages we have to write. 6 into 6 plus 1 is 6 volts. Okay. Okay. So instead of writing 6, it's better we can start with 2 ohms. 2 into I. This is 2 into I. Next 6 volts. So plus 6. Next 2 into what is the current? 0. So you can write plus or minus, it doesn't matter. Where is it? Ah, yeah. 2 into 0. Next, this 10 volts. I have considered minus 10. Why? Because if I considered arrow mark like this and if current is flowing like this, since I have considered this voltage as positive, the from negative to positive current is flowing, arrow mark is like this, so this should be negative. Similarly, VThevenin also should be negative. So VTH minus VTH. So simplify this. I value you already we have determined I value, that is minus 0.75. Substitute that and simplify, you will get VTH is equal to minus 0.5, sorry, minus 5.5 volts. Okay, it's not 0 but it is minus 5.5. That means that the terminal B is positive with respect to you, then VThevenin will become plus. Okay, so it may be a bit confusing, but you people assume some loop current. Just assume there is no current flowing in across the open terminals. We are just writing the voltage equation here to determine VTH. That's it. So there is no current. That's why you just see here. What did I write? 2 into 0. Okay. Even if current is not flowing, voltage will be there. Remember, across open terminals, even if current is not there, voltage will be there. So did you complete? Just write it down quickly. I will conclude this session. I hope you have written. I'm changing this slide. Next, step number 2, to find RTH. So voltage sources, all 3 voltage sources were there. So voltage sources should be short circuited. Short circuit all voltage sources. Okay. And just from terminal, assume current is flowing. Of course, there is no current, but we will assume. So current divides here means these 2 ohms and these 2 ohms are in parallel. Current will flow like this. Current will flow like at this junction. Current is adding and entering here. So 2 and 2 are parallel. If we simplify 2 into 2 by 2 plus 2, you will get 1. Okay. So that 1. This is 1 ohm. This resistance 2 ohms. Okay. So this is RTH. So this 1 ohm and 2 ohm both are in series. This 1 ohm, this 2 ohm both are in series. So 1 plus 2, you will get 3 ohms. So R Thevenin is 3 ohms. Draw the circuit, write the equations quickly. Okay, then we have VTH, we have RTH. What next? We have to draw the Thevenin's equivalent circuit. So RTH, what is RL? No need to determine RL, but I have added one step here. Simply have to, if you can add as many steps as you want. Okay, so it's your wish. It's your problem you can solve in the way that you want, but you must follow some rules. That's it. That is nothing else. So RTH is nothing but RL. So write down RTH value 3 ohms and draw the Thevenin's equivalent circuit. Draw it quickly. And the next step is to determine maximum power. That's it. We will conclude this session. Okay, I hope you have written. Next, to calculate or to find P maximum, formula is VTH square by 4 RTH. So you know VTH, that is 5.5, RTH is 3. Just to substitute the values, you will get P max is 2.52 watts. If you conclude in form, I will just upload the Google form in the chat box. If you complete, just inform. Okay, so let us fill the Google form and conclude this session. Check the Google form. Fill the Google form. If you complete filling the Google form, just type C, and next session will start at 3 p.m. Fill the Google form. If there is any issue, just mention. Are you able to fill or not? Please inform. After filling the Google form, just mention in the chat box. Yeah. So I can see responses. So I think there is no issue with the Google form. Join the next session. I will discuss another topic at 3 p.m. After filling the Google form, you can leave the session. Okay. Those who have completed can leave. You can leave the session after filling the Google form. Okay, I'm concluding. The responses are not increasing. That's why I'm concluding.